Welcome to XI to I. I'm Noel Rappin, and this time our talk is entitled, Help, I'm Stuck. What do I test next? Turns out I wasn't quite sure what to do for the video this week. I was stuck, and then I realized being stuck is a topic. A lot of times, people get stuck. They wind up in front of a blank text editor such as this one. They have a feature to do, they want to do TDD, but they do not know what to do. They cannot think of what to test. That question sometimes presents itself a couple of different ways. Sometimes it's, what do I test next? Sometimes a little bit slightly different angle on it. Sometimes people say, how can I make my tests valuable? Or alternately, I don't think I'm getting much value out of these tests. They seem to be wasting my time. What am I doing wrong? Or why is testing so bad? Or maybe, why do I even need to test at all? Starting from the question of why you need to test at all, we're going to work off the assumption here that in TDD, tests have three main purposes. My list here may be a little idiosyncratic. You'll see people have other lists of why tests are valuable. This is my list, and I'm sticking with it for the moment. First of all, I use tests to provide design feedback. The tests act as a kind of universal client API where the tests allow me or force me to create a clean, visible, deep API into my code that sort of encourages it to land into small pieces that are easy to maintain and easy to manage over time. Secondly, of course, tests validate my assumption that what the code is doing. That's different from saying that the code is right, but it is saying that I can make an assumption about what the code is actually doing and automatically validate that that assumption is correct. And finally, tests provide protection against regressions. So later, when I change my code, if I change my code in a way the functionality changes, a test should break. How do I get there? When I start a new feature, what do I test? So let's just to make this a tiny bit more concrete, let's say that I have a feature, I'm doing some sort of e-commerce site, and I want to say when a user submits this particular form, an item gets purchased. Where do I start? There are two basic places to start, one of which is the behavior-driven development outside-in approach, where you start with some kind of end-to-end test, so you create some specification for the behavior of the system as a whole, and you know that that end-to-end test is going to fail until all of the pieces of the functionality are lined up and working together. Often that takes the form of a cucumber test that's external to your Ruby code in a Rails application often. And it might look something like this, purchase, which I misspelled there, given a logged in user. When the user submits a purchase form, then the user has purchased an item. I prefer to keep my cucumber test very high level. This is conceptually what an end-to-end test looks like from Cucumber perspective. It is external to the code. It treats the code as a black box, and it sets up some data, triggers an action, and then validates some kind of response. You can also do that internally, where it's usually called an integration test. Capybara and RSpec can do very similar things inside your RSpec code. The key to making it an end-to-end test is that it's testing the relationship between multiple different pieces of your application that are working together to provide one piece of functionality. The other way to do this is to start at the bottom and work outward. In that case, you want to start with small pieces of functionality and build out. And there are two sort of really common starting places when you're testing in that mode, one of which is just initialize, the initial state. You can almost always specify in a test one initial state where nothing's happened yet, but you know that there's some data and there are some calls to be made. So in this case, for a purchase, an initial state might be before the purchase, the user doesn't have any purchases, which might look like this. In our spec, I'm creating a user. Again, the details are sort of beside the point, and since I did this straight in Keynote, they may not even be syntactically accurate. In this case, though, we're just creating a user, and nothing else has happened. We're initializing a user, and we're saying the user doesn't have any purchases. And again, that's not the end of the testing. That's the beginning. That's the place to start. You start with some kind of initial status. Another kind of initial state here might be that you can initially create stuff. You might start by saying a purchase can be created from form data. So you might have an RSpec test that looks like this. This is certainly oversimplified given what kind of data you might need in an actual purchase, but here I have a data hash. I'm passing it to some sort of class method that would create a purchase object, and I'm making a statement that that creation takes place. This test is just a place to get started. Sometimes even this kind of initialized test, you will find as you reach the end of it, you'll find that this test is actually no longer valuable because all of its functionality has been subsumed by later tests. But it's a good place to get started and begin the TDD process, both in terms of having a test and in terms of the design process, where it forces you to start thinking about what these objects look like, what messages they receive, what data they're going to need in order to handle those messages, and what kind of API you want those objects to present to the rest of your application. The next thing you want to test is the main happy path. Normal data, no error cases, things happen as expected. In an algorithmic case, that's usually fairly easy. So for instance, here's a really simple algorithmic test to determine the subtotal of an item. This is very much the happy path. I've got a cheap item, I've got an expensive item, I create a purchase that has, again, a slight syntactic error. I have a purchase that has two new items that are cheap and expensive, and I'm saying that I expect the purchase subtotal to equal 110, to equal the sum of those two prices. And again, this is a very basic place to start. This is the expected data, this is the expected result. That works really well when you have a very algorithmic feature. If you have something more like a purchase that is a complex story made up of a number of different parts, then what you want to try and do is break that story down into individual pieces that are more algorithmic, are more amenable to quick happy path kind of testing. And in the case of this purchase, things might be the creation of data, which we kind of already saw with the creation of form data, calculation of price, the thing that we just looked at. Validating whether the data is accurate might be a separate piece to treat in a happy path. And the actual act of dealing with the gateway to make the payment might also be another small piece of this. So you want to break that large task down into small units that are amenable to individual happy path tests. And then you might write integration tests to tie them together. Once you get a happy path in, then you start looking at non-happy path. So one thing to look at this is to worry about what would break existing code. Often when you do a happy path test in TDD, you create a really simple implementation. Sometimes it just returns the same literal that you're expecting from the test. And then a very obvious place to go for the next test is to find something that will break it. A different data that's even instead of odd, although obviously that's not a real use case, but passing in a 0, passing in a different number of items. And this is going to sort of happen in the moment as you go back and forth between your tests and the code. Your code implementation will sort of imply pieces that are missing that need to be driven by the next test. Eventually, you will want to get into non-happy path data. Create a test that simulates an error condition. Often mock objects are helpful in that. And what you want to do here is use your non-happy path data to drive the continued part of your design. You create a test that creates non-happy path data, and what that does is force your original algorithm to get more complex to handle the new error case, but it allows it to become more complex in a controlled kind of a way, where ideally you never wind up with more complexity than you need, and the overall system retains a certain simplicity. When you think you're done with the TDD process, when you feel that you've covered all the cases, the thing you need to do then is manually test it. There's no sense that TDD is a substitute for all other testing, just that as a design discipline, it allows you to get to a final design faster and with more clarity than you would otherwise. In a web application, there's no substitute for going into a browser and punching in and making sure that things actually work. This is where you validate whether your assumptions about how the code should behave actually are true in the real world. So in the manual test, you may find that you have named individual units differently in different places, or your handoff from one layer to the other is incorrect. Ideally, you would have already caught those in an integration test, but sometimes that doesn't quite work. But the important part here is that you feed those errors back into your system through TDD. I've noticed that this code does not behave as tested. That's essentially a bug, and I try to reproduce that with a test. This will help in a couple of different ways. It helps prevent regressions, obviously, because you have another kind of regression that you are testing against, but it also helps drive the design because you are using the test and the test failure as a way to make changes in your code in a way that it corresponds, that it is still tied to a client, to an API call as part of a test, and not a case where you're making the code complex sort of under the surface in a way that's hard to get to. One of the great things about TDD as a design discipline is that you treat everything as though it might break, and therefore there's an easy break glass in case of emergency way to get to almost all parts of your code. So when you have an error, you want to feed it back into the rest of the code through TDD. Also, remember to refactor. That's a really critical part of the TDD process. When you get to a point where your tests are green, look around for duplication and for abstractions that might be waiting to be teased out from methods. Look out for methods that are complicated. Clean things up. An important piece about what to test too is you want to test the behavior, not the implementation. Make sure that if the implementation changes in a trivial way, you're not going to break tests. Finally, one other thing that's worth pointing out is that if you're writing a lot of tests that already passed, you're not really doing test-driven development. Sometimes in TDD, the implementation does get ahead of tests, and you do write a test that is already passing. But if you find yourself doing that a lot, it means you're no longer really writing the test first, and you're no longer using the tests as a spur to evolve the design of the code. So that's something else to think about. In a future XI to I, we'll talk a little bit about what to do when you're stuck because a test is failing, and we'll show some more detailed examples of how this plays out. But I hope that this sort of more general overview is valuable. If you like what we're doing here, you can look this up at tablexi.com. You can also find all of the XI to I videos off the blog there. You can also follow TableXI on Twitter at TableXI. If you like what I'm doing, you can find out more about me at noelrappin.com. You can follow me at noelrapp on Twitter, and you can also purchase my book, Masterspace and Time with JavaScript, which talks about some of these testing issues as they apply to JavaScript, as well as a number of other things. And so I hope you like it. Thank you very much, and we will see you next time. Thanks.